Hello friends, grab your coffee, grab your cookie, and today, keep both away from any makeup tables because we are talking about cosmetic dust. Yes, the beautiful, colorful, shimmering dust from powders, pigments, eyeshadows, blushes, fillers, and mineral makeup that floats like smoke, sticks to everything, and can behave like a combustible organic dust under NFPA standards. My name is Michael Klepik, and for 15 years I have been designing dust collection and filtration systems for cosmetic manufacturing, powder filling, pigment blending, and clean processing environments. Let me show you why cosmetic dust is far more dangerous than it looks. What cosmetic dust really is, technical description: cosmetic dust is generated from loose powders, mineral makeup, pigments and colorants, talc, mica, and silica fillers, titanium dioxide and iron oxide powders, fragrance and binder powders. Technically, first, particle size ranges from 0.2 microns to 50 microns. Second, the airborne fraction from 1 to 10 microns is the most hazardous. Third, bulk density ranges from 200 to 600 kilograms per cubic meter depending on formulation. Fourth, many powders contain nanoparticles such as titanium dioxide. Fifth, fragrance microparticles are highly airborne and allergenic. Cosmetic dust is ultrafine, highly airborne, and chemically diverse. Where cosmetic dust appears in industry, cosmetic dust is common in: first, mixing and blending of loose powder formulations. Second, pigment milling and micronizing processes. Third, bulk transfer to drums, totes, or hoppers. Fourth, compacting and pressing of makeup powders. Fifth, filling operations for jars, compacts, and shakers. Sixth, sachet, stick, and puff filling lines. Seventh, screening and sieving of fine colorants. Every dry cosmetic operation produces airborne particulate. Why cosmetic dust is dangerous? Cosmetic dust is hazardous for both health and equipment. Health hazards first. Fine talc, silica, and mica irritate the respiratory system. Second, pigment particles often cause allergic reactions. Third, titanium dioxide dust is a suspected carcinogen in fine form. Fourth, fragrance powders can trigger asthma and sensitization. Fifth, nanoparticles penetrate deep into the lungs. Equipment hazards. First, many cosmetic powders are combustible organic solids. Second, titanium dioxide increases dust cloud surface reactivity. Third, powders migrate into bearings, sensors, and electronics. Fourth, sticky powders clog filters and coat ductwork. Fifth, dust layers fuel secondary deflagration events. Cosmetic dust is beautiful, but dangerous. Combustibility, NFPA recognition. Cosmetic powders often contain organic fillers, starches, polymer binders, plant-based ingredients, oils, color pigments under NFPA 652 and NFPA 654. These materials are classified as combustible particulate solids when dispersed in air. Key reasons: first, particle size below 500 microns. Second, high surface area increases reaction rates. Third, static electricity from blending or filling ignites clouds. Fourth, powders form dense clouds during packaging. Fifth, dust layers contribute to secondary explosions. Cosmetic production is beautiful but combustible. Behavior of cosmetic dust in airflow. From an engineering perspective, cosmetic dust behaves like ultralight, highly airborne powder. First, it floats for long periods even in low airflow. Second, mica and talc create reflective particles that travel farther. Third, titanium dioxide holds static charge easily. Fourth, powders migrate into microgaps and joints. Fifth, fine particles embed deeply into standard filter media. I designed duct velocities from 4,000 to 5,000 feet per minute for this type of dust. Filtration equipment that works best: foliage and cartridge collector. Ideal for cosmetic powders. First, membrane-coated cartridges capture submicron particulate. Second, conductive filter media, reduce static charge. Third, pulse cleaning handles overloaded pigments and fillers. Baghouse blizzard required when dust loads are heavier. First, rugged bags manage sticky or oily cosmetic powders. Second, large chambers handle high production rates. Third, pre-separators reduce filter media impact. Industry-specific requirements: stainless steel 304 or 316, smooth interior finish, anti-static construction, HEPA or ULP-A, final stage CG, MP compatible containment designs. Regulatory compliance: OSHA NFPA CGMP. Cosmetic dust is regulated by OSHA first. General duty clause for combustible dust hazards. Second, exposure limits for talc, silica, and titanium dioxide. Third, required dust hazard analysis for combustible powders. Fourth, PPE for allergenic powders. Fifth, hazard communication and training, NFPA. First, NFPA 652, fundamentals of combustible dust. Second, NFPA 654, prevention of explosions from particulate solids. Third, NFPA 68 and NFPA 69, explosion venting and isolation, CGMP. First, prevent cross-contamination between color formulations. Second, maintain cleanable surfaces and validated air handling. Third, ensure product purity and batch integrity. Capture hood design for cosmetic dust. Because cosmetic dust is ultrafine, colorful, sticky, and allergenic, capture must be extremely precise. I design, first, fully enclosed mixing and blending hoods to prevent airborne pigment escape. Second, downdraft tables for weighing and dispensing powder ingredients. Third, extraction arms positioned close to micronizing and milling points. Fourth, enclosed filling lines for jars, compacts, or powder sifters. Fifth, multi-point extraction around pigment transfer conveyors. Sixth, sealed screening and sieving stations with integrated capture. Seventh, negative pressure containment booths for high dust formulations. Proper capture keeps cosmetic dust out of the breathing zone and production space. Cosmetic dust may look harmless and even beautiful, but it is ultrafine, allergenic, combustible, sticky, and regulated under OSHA, NFPA, and CGMP requirements, with proper airflow, high-efficiency filtration, anti-static design, and good containment engineering. We can keep cosmetic facilities safe and clean. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, makeup belongs on your face, not floating inside your ductwork. See you in the next video.